So this question says, John has a velocity of 3I plus 2J plus 4K meters per second relative to Bill. Lisa has a velocity of minus 2I minus 3J plus 4K meters per second relative to Bill. What is the velocity of Lisa relative to John? So let's visualize it to begin with. Let's imagine that we have John, and we have Lisa, and we have Bill. And it says that John has a velocity of that relative to Bill. So there's an arrow going from Bill to John. It's relative to Bill. So it goes from Bill to John. And we can say 3I plus 2J plus 4K meters per second. Then the second line says that Lisa has a velocity of that relative to Bill. So Lisa relative to Bill is an arrow in that direction. And this is going to be minus 2I minus 3J plus 4K meters per second. And it's asking, it says, given that, what is the velocity of Lisa relative to John? So it's asking for this. It's going, what is this velocity? And this is a classic relative velocity problem. And for relative velocity problems, there's an equation that links what you want with what you need. And it says the velocity of Lisa relative to John is equal to the velocity of Lisa relative to Bill plus the velocity of Bill relative to John. And the way I could work that out was because I want to start with Lisa. And so Lisa goes at the beginning and at the beginning. And I want to end with John. And so John goes at the end and at the end. And the link between the two of them is Bill. And Bill is sandwiched in between. So there's my classic equation. What I've now got to do is work through what I know and change things if I don't have the right thing. The first thing is that I want the velocity of Lisa relative to Bill. And if I look at this thing, I see I have the velocity of Lisa relative to Bill. It says Lisa has a velocity of that relative to Bill. So I know this velocity of Lisa relative to Bill. And I was given this. It's minus 2I minus 3J plus 4K meters per second. So that's my first piece of information. Then the second thing I need is the velocity of Bill relative to John. And if I look here, what I see is that I actually have the velocity of John relative to Bill. I have the opposite of what I want. So the velocity of Bill relative to John is equal to minus the velocity of John relative to Bill. That's an important thing to realize is, the velocity of Bill relative to John is equal to the opposite of the velocity of John relative to the Bill. So then the velocity of Bill relative to John is equal to, rather than plus 2I, I want the opposite, which is minus, rather than plus 2I, I want the opposite, which is rather than plus 2I, rather than plus 3I, I want the opposite, which is minus 3I. And rather than plus 2J, I want the opposite, which is minus 2J. And rather than plus 4K, I want the opposite, which is minus 4K meters per second. So now looking at my equation, let's do a grid. I have I, J, K, and let's have a few columns. And the first thing I'm going to put down is the velocity of Lisa relative to Bill. And I look over here and I say it's what? It's -2, -3, and +4. And then I look and say, well, okay, what is the velocity of Bill relative to John? And this is going to be -3, -2, and -4. And then according to this equation, the operator is addition. So I need to add these guys together. So I have -5i minus 5j plus 0k meters per second. So that should be my answer. Let's see if it's there. -5i minus 5j. There's my answer. So I began by going from the word problem to a visualization. I then recognized that it was a relative velocity type problem, and I wrote down a standard equation. If I start with Lisa, I must start my right-hand side with Lisa. If my left-hand side ends with John, my right-hand side must end with John, and Bill is the link in between. I then rearranged the information where needed so that I had the velocity of Lisa relative to Bill and the velocity of Bill relative to John. I then did my math. I just said add them together and I'll get the right answer. And there's my answer. So there we have it.